Today we're learning to find the equation of a straight line between 2 points, and what we're going to do today is we're going to be using an alternative formula, and the formula we're going to use is y minus b is equal to mx minus a, where m is the gradient when we see it in this formula, and a and b would be a point that's on the line. Okay, so the way this formula is made up is basically just made up from the gradient formula. So if I think about the gradient, remember that's going to be my vertical height if I choose 2 points. So I've just chosen 2 points. I've just called one of the points there A, B for my x and y coordinate, and x and y for the, believe it or not, the x and y coordinate. Right, so remember what we've got is with the gradient is equal to the vertical height. So that vertical height there is y take away b, okay, for here. Y take away b, just like we've been doing with our gradient formula. And this horizontal length from that point to that point along the way is going to be that coordinate take away that coordinate. So just like we've been doing with the gradient calculations. So that's x minus a, and that's y minus b. So basically what we've got here is we've got a gradient. So if I worked out the gradient based on these 2 points, well, it's going to be the vertical is going to be y minus b, and the horizontal is x minus a, and these are equal to the gradient. Usually we see it the other way around, m is equal to y minus b all over x minus a. But if I rearrange that equation there by multiplying both sides by this thing here, the x minus a, so the x minus a's on this side would cancel. That would leave me with y minus b, and on this side here on the right, what I would have is I've got the gradient multiplied by the x minus a. So that's how the equation's just basically made up. But this is the equation that we're going to use. This equation here is generally used at higher maths because sometimes it helps us out with some of the equations that we get for the straight line when we're going to use simultaneous equations with. Okay, right, so let's go and do some questions based on that new equation that we've got. Okay, so the questions that I'm going to do today, they're going to be the same questions as we did in the previous video, but I'm just going to use a different formula. Instead of y equals mx plus c, which I thought was quite straightforward when we got to use that, I'm going to use y minus b equals mx minus a. So remember, m's a gradient, a and b are going to be one of the points that I'm going to use. Okay, so for this equation here, I need to find one point that's on the line. Well, I'd be told that A is on the line and B is on the line, so I've got 2 points, so I can use either that one or that one there. Okay, the gradient is equal to, well, I don't know it, so I'm going to have to work out the gradient for each of these questions. And what we'll do is we'll just go ahead and do it. So remember the gradient equation for the gradient, it's equal to y2 minus y1, so that'll be the points, and x2 minus x1. So I'm going to label up the first one just so you can see it. So that's my first point, so that's x1 and that'll be y1. This is my second point, so that's going to be x2 and y2. Okay, so for this one here, we're going to use that equation there. I'm just going to be substituting the numbers straight in and working out my gradient just to save a little bit of time for us here. So my gradient's y2 minus y1, so it's 7 take away 3. And 3 take away 1 on the bottom. So on the top, 7 take away 3 is going to give me 4. That'll give me 2 on the bottom. 4 divided by 2 is 2. Okay, so that's my gradient of that the line that joins these 2 points that are here. So I'm going to choose one of the points, and the one I'm going to choose all the time for these questions, I'm just going to use the first point. You can use the second point if you want. Sometimes it's better. But I'm just going to use the first point for consistency here. So that's going to be my A value is 1, my B value is going to be 3. Remember, I'm using this equation up at the top here to work this one out. And it gives you an alternative equation to use rather than the y equals mx plus c. Let's go for it. So I'll write down the equation first. Y minus b equals mx minus a. What I'm going to do is I'm going to substitute my values in. So y minus whatever b is, so b is 3. My gradient I worked out was 2, x is x, and the a value is the 1, okay? And doesn't matter if I use this point as a and b here, A would be 3, B would be 7, and from there the same equation will work out at the end of the day. So all I need to do here is multiply the bracket out, get the 3 over to the other side, the minus 3, and I should have my equation. So I'm going to multiply the bracket out first. So it'll be 2x minus 2, and then all I'm going to do is I'm going to add 3 to both sides. To get rid of that, that's going to eliminate, that'll leave me with y is equal to 2x plus 1. And there's the equation of that straight line there. So we've got another 5 questions to do. When you feel confident enough with it, why don't you stop the video, try the question, see if you get the same answer as me. You don't need to watch all of the video, just need to see that the answers are correct from your working. Right, so here's the next one that we're going to work with, okay? So we've got minus 2, 0, and we've got 1, minus 6. Let's go with it. Okay, so don't have the gradient, so I'm going to work out my gradient. So it's going to be minus 6 take away 0, that take away that take away that, 1 take away, and it's minus 2. And I'm putting the 2 minuses in like that instead of just changing it to a plus. So that's minus 6 on the top. 1 plus 2 gives me 3, so that gives me a gradient of minus 2. From there I'm going to substitute into y minus b equals mx minus a. I'm going to substitute my b point, so remember I'm going to choose that as a and that as b. Okay, so it's going to be 0 going in there. M is going to be in the negative 2, x minus, and a is a minus 2 there. So you've got to be careful with your negative numbers when you see these things that come here. So y take away 0 is just y on this side, so that helps us out a bit. Multiplying this bracket out, I've got minus 2 times x, that will give me minus 2x. Remember that's going to be a plus 2 when I get these two minuses together, multiplied by minus 2, but that's going to give me minus 4. So that's going to be my final answer there. So there's my equation of the straight line. Another 2 questions here, okay? And what we've got here is we've got 2 points E and F. So I don't have a gradient, so I'm going to have to work out the gradient. So here we go. I'm going to be using that minus 3 there, take away a minus 1. That minus 3 here, because that's the x coordinate, and I'm taking away a minus 7. So minus 3, adding on 1 takes me to a minus 2. Minus 3, adding on 7 is going to take me to 4. So what I can do is divide top and bottom by 2, and that will leave me with minus a half. And it doesn't matter if I put the minus sign on the top, the bottom, or at the side, that's still a minus a half. Right, so that's my gradient, and what I'm going to do is I'm going to use one of the points here. So what I'm going to do is I'm going to use this point here, so that's going to be my A value, that's my B value, okay? Right, so let's write it into y minus b equals mx minus a, okay? So from there, I'm going to do this one in 2 separate ways because I've got a fraction, just to show you a couple of different ways that we can do that. So the first way we're going to do it is, let's go for, let's substitute in first of all the values that we've got. So y minus 1, okay, is equal to minus a half, and that's going to be multiplied by x minus, and that's a minus 7 that we chose there, okay? Right, so I'm just going to tidy this up just now so that you can see what we've got, okay? So it's y plus 1 is equal to minus a half, and that's going to be x plus 7. Okay, there's 2 different ways that we can go here. What I can do first of all is, I could just multiply that out by a half. So that leaves me with y plus 1 is equal to, that's a minus a half x, and minus a half times 7, or a half of 7 is 3.5, or remember with fractions, we multiply the tops along the way. So that's going to give me a minus 7 on the top, and 2 times 1 is just 2. So that's going to be minus 7 upon 2 that's there. Remember 1 over on this side, I'm going to have to take that over to the other side. So I'm going to take 1 away, but I'm going to think about it as 2 over 2. So I'm taking 2 over 2 away. And on this side, I'm going to take 2 over 2 away as well, or 2 halves. So that leaves me with y on this side because they get eliminated, and that leaves me with a half x minus, and I've got minus 9 over 2 sitting there. So that's one way to do it. The other way to do it, and I think this is the way I would generally do it when I'm working in with higher maths, what we would do is we would multiply the left-hand side by the bottom, by the denominator on the fraction. So I know it's a negative 1 over 2, so I'm going to assign the negative to the 1. So that's a minus 1 on the top and a 2 on the bottom. So 2 times y gives me 2y. 2 times the 1 gives me a 2. I've got minus 1 times x will give me minus x, or minus 1x. Okay, I'm going to put a 1 in just so you can see what's happening there. Minus 1x, and minus 1 times a 7 gives me a minus 7. So if I tidy that up by subtracting 2 from both sides, that will give me 2y is equal to, and that's going to be minus x minus 9. So that's a bit different from that. But sometimes at higher maths, that's a good way to have the equation when we're starting to do simultaneous equations to find where lines coincide or where they intersect. But what I want to do from there is I want to get y is equal to. So I'm going to divide both of these things here by 2 to work it out. So y is equal to, so that's minus 1x, so that's going to be minus a half x, and dividing the 9 by 2, I've got minus 9 all over 2. And that's my equation. So both of these are the same, but sometimes that's a good way to go. And you'll get used to that the more that you practice these questions. Right, I'm going to go a wee bit quicker on the next ones and try and go through them. So sometimes I'll show it that way and that way as well, you know, for some of the fractions. Right, so this one here, let's get the gradient. So minus 5 take away minus 5, 4 minus 2, so minus 5 add on 5 takes me to 0, that'll give me 2, so 0 divided by 2 is 0. Right, so we're going to use y minus b is equal to mx minus a. Okay, right, substituting the values in, I'm going to go for that one a and that one b. Okay, so y minus 5, my m is 0, okay, my gradient 0, x and minus a 2 that's there. The good thing about this side here, if I'm multiplying anything by 0, that there is going to work out to be 0 in total. So what I've got here is y plus 5 is equal to 0. So my final answer, when I take 5 away from both sides, is going to give me, eliminating there, minus 5. So y equals minus 5. Horizontal line cutting through the y-axis at 0, minus 5, so down the way from the origin. Right then, so let's go to these questions. So another couple of fraction questions these ones should be. You can pause the video, try it yourself, and we'll see how these ones work out. Okay, so gradient. Working out gradient first of all. So I've got minus 3 take away minus 12. I've got 8 take away minus 4. So that's going to give me a 9 on the top there. That's going to give, because that's a plus there, that'll give me 12 on the bottom there. So that works out to be 3/4. Okay, when I divide the top and bottom by 3, that's going to give me 3 over 4, 3/4. Right, I'm going to substitute into y minus b equals mx minus a. And I'm going to use these points here, a and b. Okay, so y minus 12 is equal to 3/4 x minus, and that one is a minus 4 up the top there. Right, I'm going to do the same as I did up above. I'm going to split it into two different ways of doing it. So one way I'm going to multiply it out by 3/4 first, okay? So I'm going to tidy it up just so we can see what we've got here at the moment. Okay, so all I'm doing is sorting out the double negative that's there. Right then, so I'm going to multiply, let's see, this right hand side by 3/4. So first of all, what we're doing is we're going for, go to here, so y plus 12 is equal to, and what we've got is 3/4 x, so that's 3/4 times x, and 3/4 of 4. Remember, 3/4 of 4, you can divide by 4, that'll give me 1. 1 times 3 is going to be 3, so it's going to be plus a 3 that's there. I'm then going to get that 12 away from the left hand side by subtracting it. That eliminates there, leaving me with y is equal to 3/4 x, and that's going to be minus 9. Okay, and that would be my final answer there. If I did it like I would with higher, then remember with the fraction, I'm going to multiply the denominator, which is the 4, by these two parts that are here. So I'm multiplying across that way. So that'll give me 4y plus 48 is equal to. Now that I've used the 4, I've only got the 3 on the top, so I'm going to times these two things by the 3. So 3 times x is going to give me 3x, 3 times 4 is going to give me 12. what I'll do from there is I'll gather things up. So I'm going to subtract 48 from that side, subtract 48 from there. So I've got 4y is equal to 3x, and that's going to give me minus 36. Now that's not the same as that, but again, that's a good way to have it when we're dealing at higher maths. Right, so I'm going to get at y equals mx plus c now. I'm going to divide this side by 4, so we're going to divide both sides by 4. Okay, that leaves me with y on this side. That'll be 3/4 x minus 9. And these two work out the same, so that's the way it works. Okay, so let me just do another line down here. And we'll work on the last question that's here. So another fraction question here, and we'll work this one through just the same way. So we'll work out my gradient first. Gradient is equal to 4 minus 1 and 5 minus 3. So remember what I'm doing here is I'm using the gradient formula. M is equal to y2 minus y1 on the top, and on the bottom it's the x2 minus the x1 on the bottom. So I'm just using that to get my gradient. I'm just not writing that down at this moment in time. So 4 minus 1, so that's 4 plus 1, gives me a 5 on the top. 5 minus 3, 2 on the bottom. Gradient is 5 upon 2. So every time I go along 2, I got 5. Along 2, up 5. That's the way to think about your gradients. Okay. Right, so we're going to substitute into the y minus b equals mx minus a. Right, so I'm going to just use this point again, okay? I think if I was doing this normally, I would probably choose that point because they're both positive numbers, and it might be a wee bit better that I'm not dealing with any negatives there. Right, so let's go and do that, because I've got a negative 1 here, okay? So y minus 1, okay? I've got 5 upon 2 as my fraction. I've got x, and then the a value is going to be 3, okay? So what we'll do is tidy this up a wee bit before we do any work on it. So that's y plus 1 is equal to 5 upon 2 x minus 3. So I'm going to do it two ways again. Okay, first way I'm going to do it, I'm going to multiply the right hand side out, okay, by 5 upon 2 or 5 halves. Okay, so what we've got here is we've got y plus 1 is equal to 5 upon 2x minus, I'm saying it's minus because I've only got one minus sign between the two of these, so it's a negative answer, and 5 upon 2 times 3, so think about 3 is 3 over 1. So multiply the tops, so 5 times a 3 is going to give me 15, 2 times a 1 gives me 2, so that's going to be 15 over 2. Okay, so I've got 2's on the bottom. Remember this one here, a 1 is going to be 2 upon 2. So what I'm doing to get rid of that 1, I'm going to take away 2 over 2. Okay, and I'll take 2 over 2 away from this side here as well. 2 halves, basically. And that means I'm just taking 1 away. That will eliminate this side here, leaving with y is equal to 5 upon 2x, and that'll be minus, and that'll be 17 all over 2. So remember, if I've got negative 15 upon 2, or 15 halves, I take away another 2 halves, takes me down to minus 17 halves, or minus 17 over 2. Okay, so that would be my answer there. So let's go for the other way of doing it. So higher maths, if I was doing it there, what I would probably do is I would be multiplying out this side here by the denominator. The denominator's 2, so I must multiply both of these by 2. When I do that, I'm left with a 5, and I'll multiply the right hand side out by 5. I'm going to do that all in the one here. So 2 times this side gives me 2y plus 2. Okay. On the right hand side, I'm going 5 times x is 5x. 5 times minus 3 gives me minus 15. Okay, so that's me flattened it right out, get rid of the fractions that are there. I'll then take 2 away from both sides. I'll get that eliminated, and that leaves me with 2y is equal to 5x, and that's going to be minus 17. So it looks something like that there, not exactly the same. Again, that'd be good to use at higher maths, and what we're going to do is we're going to just divide by 2 to get this to work out for us. So if I divide that side by 2, divide that side by 2, I eliminate the 2's that are in the front there. So y is equal to, so I'm dividing both of these by 2, so that will give me 5 upon 2x, and finally minus 17 upon 2, and that's my finished equation for that straight line. So the straight line that goes through the point 3 minus 1 and 5, 4 will be the equation y is equal to 5 upon 2x minus 17 upon 2, or you could say it would be the 2y is equal to 5x minus 17. Both of these are the correct answer. But often at National 5, we're looking to try and find out what the y-intercept is, what the gradient is, and we can pick it off as long as we've got 1y is equal to. So an alternative formula to use, the same questions as I used the last time. I'll give you some work to try and use the formula, which is y minus b is equal to mx minus a. Okay then, so that's me finished for this part of the straight line topic. We're going to be working on some real life equations, and we'll be doing that following this video. Okay, so good luck with your National 5, good luck with your higher if you've checked this out for higher maths, and all the best for your studies.